everybody. Wanted to come to you today to do a little video lesson on potential and kinetic energy, and more specifically, how do we solve for these using some math formulas. So on Monday, I had you guys look up the formulas for potential and kinetic energy. But just to review, potential energy is equal to the mass of an object times the g times the height of the object. And this is for gravitational potential energy. So this h represents the height, and then this g is a constant depending on the pull of gravity towards Earth. So since we're on Earth and all of our practice problems today are going to be on Earth, our g is never going to change. So g for us is going to be 9.81 meters per second squared. And that's the acceleration due to gravity on Earth. So to solve for potential energy, I would need to know the mass of the object, the kilograms, the g, and the height that that object is off the ground in meters. And when I solve for that, I would multiply mass times gravity times height to get my potential energy, and that is measured in joules. Kinetic energy is going to be when the object is starting to move. So that would be Ke, kinetic energy. It's still going to depend on the mass of the object. But since it's moving, it's going to be also interested in what the velocity of the object is. And the formula is going to be 1/2 the mass times velocity squared. So mass is still going to be in the kilograms. Velocity is measured in meters per second, which will give us kilograms times meters per second squared. And that will be equal to joules of energy. So knowing these formulas, we're going to do a couple practice problems together. The first thing we are going to want to determine when we are solving for an energy problem is which formula we want to use. So an easy way to tell is if the object is moving, we're going to be solved for kinetic energy. But if the object hasn't started moving yet, like it's someone standing still or a parked car, we would solve for the potential energy that that object has. So this problem says, a diver has 3,400 joules of energy after stepping onto a diving platform that is 6.0 meters above the water. What is the diver's mass in kilograms? What kind of energy does the diver have? So I'm going to look at what the diver is doing, and it says that the diver steps onto the platform, and he or she is just standing up there waiting to jump, waiting to dive. So we are going to be using the potential energy formula for this one since that person isn't moving. So what I'm going to do is I'm going to try to find all of these variables and solve for the one I don't have. So when I reread the problem, I'm going to say, okay, a diver has 3,400 joules of energy. So that is my potential energy, 3,400 joules. And that's equal to the mass of the diver, which I don't know because it asked me what is the mass. So I'm going to leave that one as m. G is always equal to 9.81. And my h would be the height that the board is above the water, which is right here. That's 6.0 meters above the water. And then this turns into a algebraic problem where I have to solve for m. I want to get m on the right side by itself. So what I'm going to do is since these two are multiplying together, since these three things are multiplying by together, I'm going to have to do the opposite of multiplication, which is division. So I'm going to divide both sides by 9.81. 9.81 is canceled over here. I'm also going to divide both sides by 6. 6 cancels over here. And if I were to rewrite that problem, I would see that I was left with just M on that side, just the mass, and just some numbers to type into a calculator. So I'm going to grab my calculator and take 3,400 divided by 9.81 times 6.0. And I get that that diver has a mass of 57.8 kilograms. This next problem asks us to calculate the energy of a 1,500 kilogram car that's moving at 18 meters per second. So I'm just going to look at my numbers quick. 1,500 kilograms, that is telling me mass. 18 meters per second is telling me velocity. And if I'm thinking about, is this potential energy or kinetic energy, since the car is moving, that's my keyword that tells me we're going to be looking at kinetic energy. So I'm going to plug in the numbers I know, where they would go in the formula. So kinetic energy is equal to 1/2 the mass of an object, which is 1,500, times the velocity of that object squared. And if the parentheses are confusing you, I always like to put my work in parentheses so I can see just like that the mass is this number. It helps me stay organized. So you don't have to have the parentheses. They are just there to help me organize my work. So when I solve for kinetic energy, I'm just going to plug this whole side into the calculator. I can plug it all in at once if I use parentheses. Otherwise, I have to use my order of operations, which, if you think back in your memory bank, hopefully you remember that exponents come first. So that's another reason I like to use parentheses, is so that I can put it all in the calculator at once. So I would literally just type everything in as parentheses 1/2, parentheses 150, parentheses 18 squared. And when I do that, I get a lot of energy. This car would have 243,000 joules of kinetic energy. So today on your work plan, you have some more practice problems that you can be working on. So you have this whole sheet here. This would be a good one to just copy down in your notebook, like the numbers, and work on your notebook because you can't type on this one. If you have a printer, go for it, but otherwise just use your notebook. The first half is just determining, like, is it potential or kinetic energy, and which one has more. And then down here at the bottom, there's some calculations that you can go through to solve for potential and kinetic energy. Don't feel like you have to do this whole thing. If you solve a couple and you're like, oh, I really understand this and it's easy, don't feel like you have to do all of the practice problems, but you are more than welcome to. But what I'd like you to do when you are finished with them, I went through and answered all the questions. So it would just be a good idea for you to go through and give yourself a little self-check that you're understanding how to solve. That way you can ask me questions if you're getting things wrong. So do the practice problems first, check your answers. You don't have to submit either of those things to me. So you don't have to email me anything back today. Just know that tomorrow we are doing our evaluation for the week, which will have potential and kinetic energy problems on it. One little change here. we are not having Google Meets this week. But what I did instead of that is if you're feeling like you'd like to meet with me and talk to me about some things, I sent out an email yesterday about having a 10-minute meeting with me on Google Meet, so we could just talk through some things together. And that way we don't have like the whole 25 of you trying to get on a Google Meet, because it was a little chaotic last week. So if you need me and you want to talk to me that way, just go on and schedule one of those meetings with me. And I can meet with you individually and help. So today, just watch, after you're done watching this video, do some practice problems, check your answers, and when you do that, you'll be ready to take tomorrow's quiz. So I will see you and talk to you tomorrow.